crap. Okay, so luckily I can fix this webcam. Okay, so I'm gonna just so so we're basically going to dive into displacement. And what I usually do is after I finish learning something, I would just keep practicing it over and over again. Because the reason why is that especially for physics 1 and other math based classes, you need constant practices, right? So that's what we're going to do on Khan Academy. So we're gonna move on to that. I'm sorry that I kind of paused on that. It's because my teachers were calling me. So we're gonna move. We're gonna move on to Khan Academy, which is basically a website that I use to just drill in some practice from. So starting from displacement and distance, right? Okay. So I hope that my webcam is still going because I can't see it, but I'm gonna trust that you guys can see me. But all right, so we basically have okay. So first thing what we do is we read the situations, right? So see, okay, sorry about that. No, I do not want to print this. I had to pause so that I can. So we have the situation. An iguana runs back and forth along the ground. The horizontal position of the iguana is shown. So this is a um, position versus time graph, right? So what is it asking us? What is the displacement between 0 and 5? Well, do you guys remember what displacement is? Displacement is x final over x initial, right? So the final position we arrived at is 6 meters, and the position we started at is -2, right? -2 meters. So 6 minus -2 is 8 meters, right? That is our displacement. What is the distance traveled between 0 and 5? Well, distance distance is scalar, right? So I'm the iguana, right? Let's imagine that. From -2 to 6, we have traveled 8 meters, right? From 3 seconds to 5 seconds, we travel nowhere, right? So in this rare case, distance equal to displacement because we're not doing anything here, right? We're not doing anything. We're at rest for what it's called, right? So in that case, it has to be 8. Ow. I forgot to turn off the thingy, but I'm scared to like mute my desktop thingy. But you're just gonna have to enjoy that. Okay. So again, we have an elevator traveling up and down. This is the position versus time graph for the elevator, right? So, what is the displacement of the elevator between 8 and 24? Again, there goes that same concept of what is okay. So at 24, what position did we arrive at? -6, I believe. Okay. What about 8? Well, 8 we have 12. So we started at 12. We end up at -6. So -6 minus 12 is -18, right? Okay. So distance traveled between 8 and 24. Now this is what I was talking about. So I want you to imagine that you started at 12, right? 12, and then you traveled that 12 meters over a period of 8 seconds. So keep that number in your head. You traveled 12 meters so far. It doesn't matter if there's no such thing as a -12 meters. It's only meters, right? 12 meters. 12 meters. And from 16 to 20, we've traveled 15 meters, right? Again, no such thing as a -15 meters. And then from 20 to 24, we travel 6, right? So what I'm basically doing is I'm taking the distance traveled per each segment and then add it together, right? Until I reach to obviously 24 seconds. Which what we see here is we actually wait, did I? No, I did that wrong. It's 12 plus 15 plus 6, which is basically 33 meters, right? You can see here that distance traveled doesn't equal to displacement. And that makes sense because displacement is the short path that an object takes to approach another position. But distance is the scalar, long, short, whatever path that the object is taking, right? Oh, okay. Well, I got it wrong, but let's see why we got it wrong. 8 to 24, that's negative 6 and 12. Ah, there. Wait, 6 and 12, 18. Okay. Travel between 8 and 24. Well, between 8 seconds, we travel to 12. Um. Okay, so I see why I got this wrong. And I'm glad that I actually got this wrong because this is another point. From negative 15 to negative 6, how much did I travel? Well, negative 15 minus negative 6 is negative 9. But again, remember the idea that there's no such thing as a negative 9. So from here, we travel 12, right? From here, we travel 15. From 15 to 6, we travel to 9. We travel 9, right? So that's why it is 6. And that's the thing. I'm not saying that I'm really good at physics. But what I need to tell you is that you have to be very diligent in how you approach these problems. Like, you see what I did there? I made mistakes. I also make mistakes, right? And it's only because of that wrong interpretation, right? That I make. So one more, and then we gotta move on to something else. So car rolls down a ramp. Okay, yada yada yada. Okay, horizontal position. So got it. This is a position versus time graph. So from here, what we have is the position versus time graph, and it questions asks us, what is the displacement between 0 and 24? Well, at 24 seconds, our arrival time, it is 0. Is it 0 meters? Well, what we started with is 12, so 0 minus 12 is negative 12 meters. What's the distance traveled? Well, from 0 seconds to 8 seconds, we've traveled 12 minus 6. That is 6. So we traveled 6 meters, and we didn't travel anything at all for the duration of another 8 minutes. And another 8 minutes, we traveled 6. Right? 6 plus 6 is 12. And notice how the distance not have sign. Distance does not have a sign because there's no such thing as a negative meter, right? So that's just basically distance and displacement for you. Now, we're going to move on to average speed in one directions word problems, right? So, again, I'm just going to be very quick with this because it's actually not that bad. So, we are given the average speed of this, right? Average speed and how many seconds have passed. Or, yeah, average speed and the distance covered. So how much seconds have passed? Well, here's the thing. Average speed is basically average velocity but without the signs, right? So from there we can actually understand that 2.4, the average speed, would equal to distance covered, right? That's distance covered over time, right? That for me that is what the formula of speed is actually. It's just basically distance over time. So we're trying to find this time, right? So what we have here is 2.4 equals to 1.3 over x, where x is the time that we're looking for, right? So you basically just algebra from there, and what you get is two significant digits. So I'll do this for you. 0.54 seconds, pretty much. There you go. So one more because it's honestly just the same thing, it's just punching a bunch of numbers in. Okay, so this one is solving for average speed. So you can see here that the average speed is the distance covered over the period or over the time period, right? So here's the thing, to the left, remember what the question says is average speed. So you're not using average velocity formula, you're using the speed formula. So the distance covered is 1,100 meters, right? It doesn't matter if it's to the left or to the right, up, down, sideways, I don't care. It's just that distance that we've covered, right? And over 330 seconds, right? And what we have here is 3.33 repeating as an average speed, right? Notice here that there is no signs that indicate anything, right? So from there, that is basically it. Again, I want to reiterate that it is very important for you guys to just practice with these problems on your own time, because what good does it make if you guys don't practice this, right? So now we have a diagram. So the squirrel basically runs right 10 meters and then left another 20 meters, right? And the total time spent to do all these actions is, was it 12 seconds? Yes. Okay. So average velocity reaching the second nut, right? So the average velocity to reach the second nut. Okay. So from where we started, right? So remember, we start at this position, right? So what position are we starting? So if from the distance of this nut to this nut is 20 meters, but we have to travel 10 meters to get to this nut, we can reason out that the score has to start at 0, right? Right? Or basically, I think, yeah, it's just basically 10 meters away from this nut, right? So if that's the case, if this is 10 and this is 20, then we have to cover another 10 that we didn't cover previously, right? Because here we cover 10. Right? From here, follow my mouse, we cover 10 right here, right? But everything after that is a mystery, right? So what that means is we basically had a displacement of um basically 10 meters, right? Because we start in this position of 0, and then we go to this nut, which basically is 10 meters away, right? So if that's the case, then that is negative 10, right? Because remember, it's distance, so 10 minus, or negative 10 minus this initial position, which is 0, minus 0, over the time spent, which is 12. Well, there you go. That's the average velocity. It is negative, and I need to make sure that this is correct. It's too significant. Okay. Well, now what's the average speed each second? Well, average speed is the same thing, right? Average speed is basically the distance covered to get that nut, right? So we covered 10 and then another 20, right? So 30 meters in that run over 12, which is basically 2.5, right? So you can see here that the average velocity and the average speed does not align with it. But that's okay. That's okay, because that's basically it. And of course, you're going to get more problems like this, where it gets kind of more complicated. But not really. Especially like, when you're trying to figure out where this pony started out. But what we have here is the horse's average velocity reaches to the apple. Okay, so a horse travels 15, 20, and then 4, right? So I want to know the distance between the horse now to the apple there, right? Okay, so 15 plus 20. We know that's more than 15 and a little bit more, a little bit under than 20, right? So if 20, right, reaches the carrot, and we said, oh, well, we kind of overshoot it a little bit. Let's go back to 4 meters. What we do is we take 20 minus 4, and that basically equals to 16, which is the distance from this carrot to this apple right here, right? And what we have is 31 meters, right? So 31 meters from the pony to the apple divided by, let's see, the time spent, 74, right? Which basically gives you about, and do 6 fix, so 0.42. Now the horse's average speed. So again, remember how average speed is basically how much you covered, right? So 15 minus 20, or 15 plus 20 plus 4, right? That's how much distance we have traveled. 39 over 70, 74? 74. 74, that is basically 0.53. And you can practice this whenever, whatever, and however you like it. But just as long as you're practicing it on your own, this is fine. Average velocity and average speeds from graphs. So this is basically what I was talking about. Okay. What is the average speed of the graph between 4 and 10? Well, let's see here. From 4 to 10. Oh, you can see here that we have this movement and no movement and then movement. So from 10, right? So 10 is here, but 4 starts here. So remember, the average velocity, again, think about the formula, is displacement over time, right? So our final position is 5, right? Our initial position is 2. So 5 minus 2, which is 3. Then over how many seconds have passed? Well, from 4 seconds to 10 seconds, 6 seconds, 6 seconds has passed. Therefore, the average velocity is 0.5 meters per second. Again, just bring it all back, tie it back into the formula, right? So the average speed, 0 to 8 seconds, right? So the average speed. So how much distance have I covered from my running? Well, I've covered 2 meters in a span of 4 seconds, right? I think. Yes, 4 seconds. And from 4 to 8, I traveled nowhere. So how many distance have I traveled? 2. How many time has passed? 8. Therefore, my average speed is 0.25 meters. See? Okay, so one more. So 2 over 6. What is the average velocity? Well, 2 over 6, right? You can see here that we have we arrived at 2.5 meters. And to check our initial position, which is 1.5, and we get a displacement of 1 meter. And over how much time has passed, so around 4 seconds-ish, you get 0.25 as the average velocity. There you go. So you guys can understand how that would work. Next is instantaneous velocity and speed. So this is what I was talking about. Okay, so instantaneous velocity at 6. So what's happening at 6? It's not moving, right? How do you know it's not moving? Well, because what we have here at 4 to 8 is a period of time where the bird is not moving, right? So if the bird isn't moving, I want you to get this in your head. Wait, hold up. Also, this position was time. Yeah. I want you to get this in your head. From 4 to 8, the bird is not moving, right? From 4 to 8, the bird's not moving. So what's happening to the bird at 6 seconds? It's not moving, right? It's not. Because the reason why is 6 falls between 4 and 8 seconds, a period in which the bird isn't moving, right? So next stop, I'm making sure that my thing is recording. Yes. So the next diagram that we have is the instantaneous velocity. The instantaneous velocity, right? So at t equals to 6. So again, see how there's a period at which nobody is moving between 4 to 7? Well, 6 falls into that category. So you know what? It's also 0 meters per second. It's just that, simple. Now, we're going to get something like 8 right here. So you can see here that 8, you can obviously know that the object is moving, but it's the same idea, right? What we found is just basically the slope of this segment and compare that to what time interval that they're talking about, right? So like from 8, you can see here that it's at a specific point, but here's the thing. You can find the slope of this segment and just deduce that this object has been traveling for that speed or velocity for its entire duration. It doesn't matter whether you have kinematics, as long as you have a graph and the average speed, average velocity formula, right? At your disposal, you can find the instantaneous velocity, right? So what is the graph? What is the slope, or I would say the average velocity between 9 and 7? Well, 5 minus 2, 3, right? Displacement over a period of 2 seconds, 1.5. We've been traveling 1.5 at 8 seconds, right? Why? Because the slope between 7 and 9 seconds is 1.5 meters per second. There you go. All right, and finally, our last review that would bring everything together is finding displacement under a velocity graph, right? So we have the displacement between 2 seconds and 3 seconds. Well, let's see here. It's a triangle, right? So the area of triangle is basically 1/2 base times height, right? So 1/2 times, excuse me, the base, which is 3 minus 2, which is 1, and then times height, right? So from 0 all the way to, what is that, -5, which there's a negative displacement of negative 2.5 meters. Now we basically have the same situation. I'm just gonna skip through. The displacement is 1 to 2, right? So again, think about what you're doing. 0. Well, yeah. 1/2, right? 1/2 base, 1 to 2. That is, or 2 minus 1 is 1, and then the height. 0 minus -5. Yes. Hold up. I gotta think about this. uh, yes, from 0 to -5, that's -5. That's negative 2.5 meters. No, that's 2.5 meters. Sorry, my bad. Scratch that out of your head. This segment right here, this velocity, not the velocity, but the vertical line that we would deduce, that's 5. This is -5. I'm very sorry. Displacement would be still 2.5 meters. Because what I said in my PowerPoint is that everything above the 0 is a positive displacement. Everything below the 0 is a negative displacement. Ooh, so we have the chicken's displacement at 2 to 4 seconds. So what we have here is we actually have what's something called we have a trapezoid. So the bottom base from here to here, that's 2. The horizontal or the vertical distance between this to that is 5, -5 to be specific, and the distance between here to here is 1. So what we basically have is a trapezoid with a longer base of 2, a shorter base of 1, and a vertical, a vertical line of -5. So we also just use that number and plug into our formula for the trapezoid, right? Which is basically 1/2 times the addition of both bases, so 2 plus 1, times the height, right? So -5. It is -7.5. One more. 0 to 5 seconds. Yes. So this is one of the things that I want to talk about with the 0 and 5 seconds. You can see here that the displacement, there's 2. There's a negative and a positive. So you're eventually going to add those displacement once you found them, right? So let's do that. Let's find this displacement between 0 to 1 second, right? So it's a triangle. So again, I'm not even going to help you. You should be able to find that displacement all by your own. So 1, 2, cross. Oh, shoot. That's -1, right? So that's -1 meter for a displacement right here. But what about 1 to 1.5? Well, same thing idea. Same thing right here. So 1/2, right? Okay, 1/2 times the base, which is basically 0.5, and then times the height, which is basically 1. So 1 times 0.5 times 0.5, that's 0.25. So what we have here is -1 meters for this segment and 0.25 for this segment right here. So again, when you have opposing displacement, right, what you want to do is you want to add them, right? Because you want to add displacement from 0 to 1.5. We have to make sure that we're accounting for all displacements, right? So add it. So -1, add by 2.25, -0.75 as our final displacement. And there you go. So, oh my lord. So hopefully that this introduction would help you, and I'm sorry that I couldn't see the webcam. I was just focusing on doing this. But is that proportions all right? Okay. So yes, this is basically what you guys are supposed to learn, and I encourage you guys, if you're If you don't want to watch my presentation, that's fine. If you if you just need to practice, just go to Khan Academy. This is a very good website that gives you just like basic drills to just do the problems and then drill it all. Because ultimately, the skill that you need to have is basically, you know, um, basically how to approach a problem really quickly and also know what the hell you're doing, right? Because you can't when you're doing a FRQ, free response on physics, you have to understand the problem immediately and understand what the question's asking you and how you should respond to that, right? And basically that's what Khan Academy is trying to do, especially towards the multiple choice. It still helps for FRQ, but this is a very like multiple choice based format. So hopefully this helps, and I'll see you later when I'm discussing maybe kinematics or projectile motion, free fall, whatever. But yes, this is pretty much all you need to learn. So you guys have a good day.